There is an object 10 billion light-years away that is 66 billion times heavier than the Sun, and according to our own physics, it shouldn't be able to exist. For 60 years, we thought it was a star. Section 1. The mistake on the glass plate. In 1957, at the Tonantzintla Observatory in Mexico, astronomers were working through one of the least glamorous jobs in science, photographing the sky onto glass plates, one exposure at a time, hunting for faint blue stars that stood out against the ordinary white and yellow of the Milky Way. Near the border of Canes Venatici and Coma Berenices, they logged a small blue speck. Nothing special. It became entry 618 in their catalogue, filed away as a hot blue star sitting somewhere in our own galaxy. They were wrong by a factor that's hard to put into words. That speck wasn't in our galaxy. It wasn't a star, and it was already old when Earth didn't exist. Section 2. The redshift. The correction came decades later, when radio astronomy matured and telescopes started listening to frequencies the eye can't reach. Pointed at that faint speck, they found it screaming in radio. Stars don't do that. Spectroscopy finished the job. Split the light apart and you can read what an object is made of and how fast it's moving. And the light from this thing was stretched, shifted deep toward the red end of the spectrum, the signature of something receding at an enormous fraction of the speed of light. Run the numbers and the distance comes out at roughly 10.4 billion light-years. The universe is 13.8 billion years old, which means the light that landed on those glass plates in 1957 set out when the cosmos was less than a quarter of its current age, back when the first generations of stars were still switching on. It had been traveling for 10 billion years to end up as an unremarkable dot in a filing cabinet. Section 3. What it actually is. At that distance, an ordinary galaxy would be invisible to us. A single star would be beyond hopeless. So the only question that matters is, what could possibly be bright enough? The answer is a quasar. Quasars are the violent cores of young galaxies, powered by supermassive black holes in the middle of a feeding frenzy. Gas, dust, entire star systems get pulled in, but they don't fall straight down. They spiral, flattening into an accretion disk, and inside that disk material is dragged around at a serious fraction of light speed. Friction does the rest. Temperatures climb into the tens of thousands of degrees, and the whole structure ignites across the electromagnetic spectrum, radio through visible light, through X-rays and gamma rays. TON 618's disk burns so violently that it drowns out the entire galaxy around it. We can't see the host. The glare erases it. Section 4. The brightness. So how bright is it exactly? Astronomers put its absolute visual magnitude at around -30.7. That number is meaningless until you convert it. This single object radiates with the output of roughly 140 trillion suns. Here's the thought experiment. Take TON 618 and drop it into the center of the Milky Way, replacing what's already there, from 26,000 light-years away, a distance that renders most things invisible. It would outshine every star in our galaxy put together. It would sit in our sky more than 20 times brighter than the full moon. There would be no night, ever. Just a permanent scalding twilight and a flood of hard radiation that would strip our atmosphere and sterilize the surface long before anyone worried about the view. Section 5. 66 billion suns, but all of that light is just exhaust. The engine is the thing worth being afraid of. The black hole at the center of our galaxy, Sagittarius A star, weighs about 4 million suns. That's already a monster by any human standard. TON 618 is estimated at 66 billion solar masses, more than 16,000 times heavier. That number pushed it out of the supermassive category entirely. Astrophysicists had to invent a new bracket for objects like this. They call them ultramassive black holes, and there are only a handful of candidates in the entire known universe. Section 6. The limit it broke. And here's where it gets genuinely strange. Theory says there's a ceiling on how big a black hole can grow by feeding. Past roughly 50 billion solar masses, the radiation pouring off the accretion disk gets so intense it starts pushing the surrounding gas away faster than gravity can pull it in. The black hole effectively starves itself. That balance point is tied to what's called the Eddington limit. TON 618 sits at 66 billion. It's past the ceiling. Whether that means our models are incomplete, the mass estimate is too high, or it grew through a route we haven't accounted for. Mergers, an unusually heavy seed. Feeding conditions in the early universe far more extreme than we imagined. Nobody has settled it. It exists in defiance of the math that describes it. Section 7. The size of the dark mass is abstract. Size isn't. A black hole's event horizon is the boundary where escape becomes impossible, where the speed you'd need to get away exceeds 300,000 kilometers per second, and light itself can't manage it. For TON 618, that boundary is a sphere something like 400 billion kilometers across. The Sun to Pluto is about 5.9 billion kilometers. So take our entire solar system, everything from the Sun, out past the orbit of Pluto, and drop it in. It vanishes, and there's room left over for dozens more alongside it. Section 8. Approaching it. So what would it actually be like to go there? You'd meet the jets first. Magnetic fields wound tight around the black hole fire twin columns of plasma out of the poles at nearly light speed, stretching for millions of light years, long enough to reach clean out of the host galaxy and reshape it, blowing gas away and shutting down star formation across the whole thing. Get past the jets and past the burning disk, and you'd see a halo of light wrapped around a sphere of nothing. That halo is starlight being bent backward by gravity, caught in orbit before it falls. Then time turns on you. The closer you get, the slower your clock runs compared to everyone else's. Hover near the horizon, and seconds for you become years, then centuries for the rest of the universe. To anyone watching from a safe distance, you'd appear to slow, dim, redden, and freeze. A ghost stuck at the edge, fading forever without ever quite arriving. And the colors go wrong. Light climbing out of that gravity gets stretched, so everything you see shifts crimson, like the black hole is draining the color out of the sky. Cross the horizon, and none of it matters. There's only one direction left, and it ends at a point where density becomes infinite and physics stops being able to describe anything at all. Section 9. The problem it creates. The real trouble with TON 618 isn't what it does, it's when it did it. Black holes this size are supposed to take a very long time to build, starting from stellar remnants or collapsing primordial gas clouds, then feeding and merging for billions of years. But we're seeing TON 618 as it looked over 10 billion years ago in a young universe. It got to 66 billion solar masses in a hurry. Either these things start out far heavier than we assumed, or the early cosmos was a denser, more violent feeding ground than the models allow. Either way, something in the textbook is wrong. Section 10. The long death. And yet even this doesn't last. Trillions of years from now, after the last stars have burned out and the universe has gone cold and dark, black holes will be the only significant things left. But through Hawking radiation, they leak. Slowly, quantum mechanically, they bleed mass into empty space and evaporate. For something the size of TON 618, that takes a span of time written as a 1 followed by 100 zeros, a Google of years. Then even it goes out, in a final flicker, in a universe with nobody left to notice. Until then, it hangs there in our data as the closest thing we have to a contradiction we can photograph. But quasars like this one aren't only monsters. Their light has crossed 10 billion years of intergalactic gas to reach us, and everything it passed through left a mark on it. Read those marks and you get the chemistry of the early universe, the distribution of dark matter, the shape of the first galaxies forming. The most terrifying object we've ever found is also one of the best lamps we have for seeing the past. What would you want to see if you could stand at a safe distance and watch it feed? Tell me in the comments, and subscribe if you want more of the universe's worst neighborhoods.